Hi, in the last video I explained what aquatic invertebrates were, their roles in aquatic ecosystems, and why ecologists study them to assess stream health. So in this video I'd like to explain how ecologists use what we call biological indices or biotic indices to convey information about stream health to the non-ecologist. Now, as you can imagine, we would collect a huge variety of invertebrates at different sites throughout the region. We might go to a site and find between 10 and 20 different types of invertebrates. So by the time we've gone to say 10 sites, you might have a total invertebrate species list of 30, 40 or 50 different animals. The Council currently collects samples from about 130 sites throughout the region. So if each of these sites contained their own particular suite of taxa, we might end up with a huge table of different combinations of taxa found at different sites. Now imagine then we've gone back every year for between 10, 15 or 20 years. And this is what we have here. This is a huge Excel table of just the monitoring that the Council's done. These are our sites, NERM 1, 2 and 3. And we've got 1,654 different samples collected from right across to 140 odd taxa. So that's a very, very complicated table. So how on earth can we as ecologists try and explain all this information to managers who are definitely not ecologists? Now this isn't a unique problem. I mean, after all, many of us have been to a doctor and asked for a health check, and doctors do things like definitely take measurements of pulse, respiration, blood pressure, weight, height, cholesterol, blood sugar. They do all these measurements. And the challenge for both doctors and ecologists is to distill all this information that we collect about various parts of a patient's health or various parts of stream health, and to determine whether a patient or a stream is in good health based on this information they collect. Now, one of the things that ecologists have done is to develop what we call biological indices. And these are basically some form of a number that represents a specific part of the community or the invertebrate community which responds in a predictable way to known environmental stresses such as excess nutrients or excess algae or excess sedimentation. Now, one of the most common biotic indices is called the Macroinvertebrate Community Index, or the MCI, and this is based on the known response of invertebrates to organic enrichments. Now, this index was developed by the ecologist John Stark in the late 1980s when he sampled invertebrates above and below dairy shed effluent. And as you can see from this presentation, or this representation here, he noticed that some taxa were found only above the dairy shed effluent, but not below, whereas other taxa, as you can see down here, were found only below the dairy shed effluent and not above. So based on the distributional pattern of these different invertebrates, Dr. Stark assigned what we call tolerance scores to the different types of invertebrates. So for example, invertebrates which were tolerant to organic enrichment and found below the dairy shed effluent were scored very low, and invertebrates which were only found above the dairy shed effluent were scored very high. So to calculate the ecological health of a stream, it is a simple matter to look at the individual tolerance scores of each of the different animals and add them up. We then calculate the average of all those tolerance scores for that particular site, and then we just multiply by a simple scaling factor of 20. So the resultant MCI scores can range from values less than 60, which indicates probable organic enrichment or low water quality, right through to 120, which indicates excellent water quality conditions and good ecological health. A problem with the MCI, however, is that it considers only the presence or absence of a particular animal. So imagine two streams, as you can see here. Stream A has got 10 mayflies and 1 snail, and stream B has got 1 mayfly and 10 snails. Now, ironically enough, as we can see here, the MCI scores are identical, despite the fact that the overall relative contribution is very different. This is when the quantitative MCI, or the QMCI, is very, very useful. And you can see clearly that stream B has got a much lower QMCI because it's got more of these tolerant animals. So in my opinion, the QMCI is a far better way to assess stream health, as it measures both what species are there, but also their relative abundance. And I think this is very important to know, as we could detect a decrease in QMCI scores as the densities of sensitive taxa decrease. And if the cause of this reduction can be identified and remedied, then we could have stopped the stream from degrading and becoming unhealthy. But if, however, we just rely on the MCI, then by the time the MCI has changed, some of these sensitive animals might have been lost to the system totally, and then it might be too difficult or expensive to restore the stream to get these animals back. Now, another index that ecologists used is based on the fact that mayflies, stoneflies and caddisflies are sensitive to organic enrichment or sedimentation. In contrast, other invertebrates such as snails, midges and worms are not sensitive to these stressors. Therefore, a simple assessment of the number of mayflies, stoneflies and caddisflies, as you can see here, is a very good measure to assess ecological health. So this index is simply called the Ept Index, and it stands for Ephemeroptera, which is a technical word for mayfly, Plecoptera, which is a technical word for stonefly, and Trichoptera, which is caddisfly. So as you can see here, sites with good stream health have got a high number of EPT taxa, or a high percentage of EPT taxa, and sites with low EPTs have got poor stream health. So a final problem with using indices such as the MCI or the QMCI or EPT is that they were not developed specifically for the Bay of Plenty. And these indices also assume that invertebrates respond in a consistent, predictable manner to stresses such as sediments, nutrients or temperature. This assumption may or may not be valid, especially given the great diversity of streams in the Bay of Plenty. For example, some of our streams naturally have coarse stream beds, and some of our streams are naturally dominated by fine pumice sands. So should we treat all these streams the same? Should, for example, the absence of EPT taxa in a natural fine pumice stream bed be regarded as being bad? So a simple way around this, as you can see by this next slide, is to compare the invertebrate communities at a particular site with those found in a similar site but where minimal land use change has occurred. And these sites where minimal land use change has occurred are called reference sites. So for example, we could look at the health of a pumice stream flowing through an urban catchment to the same type of stream flowing through a native bush catchment. And we just normalise the invertebrate metrics by dividing the value of the metric in the urban by the value of the metric in the native bush. So by normalising it, we actually make things relative to the standard reference condition for that stream type. So I've done this in the Bay of Plenty, and I've created a new index which I've called the Bay of Plenty Index of Biotic Integrity. And I'm actually currently working on a report, State and Trends in Invertebrate Health in the Bay of Plenty. And that basically shows that the BOP-IBI seems to work as well or probably better as the MCI or the EPT. And so this BOP-IBI basically just looks at the ratio of the different metrics between a particular site and an equivalent reference site. So there we have it, different ways to express ecological health. So I recommend that we need to look at all these different ways, as they are all telling us slightly different things about ecological health. And, like a patient visiting a doctor, I'd be very cautious in just using a single measure to assess stream health. I mean, after all, how would you feel if a doctor only took your blood pressure when you went for a checkup?